Hi everyone, it's good to be after lunch when everybody is awake. So my name is Omer Zohar, and with me here is Roee Avni, and we're from Aero Security. So back in October of 2018, Apple has released its latest OS version, which is macOS Mojave, along with Safari 12. So it had a lot of changes, and especially for security, it had some interesting security features to improve, supposedly to improve how they fight malware and detect it, and for privacy stuff. So now we are 9 months afterwards, and we decided it's a good idea to really see how these changes were affecting the malware scene, and especially common malware, and whether or not these types of changes even had any effect on how malware behaves. So presentation is not just a single presentation. It's a work that has been conducted by the team at Aero Security Labs for the past couple of months. It's a combination of a lot of tweaks and behaviors that we saw over the past couple of months in macOS Mojave. Some of them were also in the previous version, and some of them are brand new for changes that were made in macOS Mojave. So let's start by a few numbers. So it's nice. So when we talk about common malware, we're talking about we break it down to several categories. The first category, and maybe the most important one, is the adware/installer category, which is basically the way that most malware gets distributed today, by either fake installer that get some fake application to the user's computer, or to a valid application and stuff like that. And while they're installing this application, they also get infected and some stuff happening in the background. So we have extensions which are basically used to search hijacking, scareware, most of the fake AVs and the cleaners out there. And of course, cryptanalysis, the past couple of years has been really popular. And the rest are the more sophisticated stuff: Trojan, rats, nation states, whatnot. In total, we estimate our numbers show that roughly 26% of Macs out there are infected in one way or another, and it continues the year-to-year growth of since 2015 of almost 100% in number of infected machines, which is more or less in line with how many Macs are out there. So as I mentioned before, most malware are get distributed as a bundle through scareware or some other application. These are funnel attacks rather than targeted. It's basically it uses a lot of social engineering and bad user habits to get installed, rather than we don't see a lot of uses of exploit, for example. So in this presentation, I will not show you even one exploit, but it does have a lot of sophistication. For example, we see a lot of customized experience for the users. We see a lot of location fingerprinting and pick and choosing of machines to infect based on origin, machine type, whether or not it's a VM, whether or not it was infected before, and stuff like that. So it really does a lot of stuff dynamically in order to prevent and to better monetize on users, and to make it hard for researchers to actually look into this stuff. And finally, all this, especially the adware part, is basically an industry. It's the activities are on the fine line between between malicious activity and what's legal, and they always thread this fine line. And a lot of these get distributed by various companies that people are working at and coming to work every day, and they roll multi-million dollars in revenue each year. So let's see what happens in macOS Mojave. This is our estimated newly daily infected machines before and after in the past year or so, before and after the launch. And you can see the trend is basically not changing a lot. And today we are at 56% adaptation of macOS Mojave, which is exactly the number of installation that High Sierra was before Mac was launched. That means that transition to Mojave is basically done. So the bottom line is that it seems that attackers have adapted. So the change to the new OS may have a little bit changed their behavior, but not their infection rate. So basically means that there is no big change here. So let's talk about keychain. We're gonna walk in the next few slides. We're gonna walk you through several behaviors that we've seen. From the moment the user gets infected through all sorts of interesting parts that they encumbers that the malware have to pass in order to get installed in the machine and monetize the user. And the first one is code signing. Most malware arrive bundled in some other application, and as such, it has to have some developer ID that is properly code signed. Apple, of course, sometimes will revoke certain certificate if they get complaints or if they find in other ways that something malicious is going on, but they are very, very slow to respond. Sometimes it takes between days to a few weeks for a certificate to get revoked. And actors are aware of this fact, and they're already ready with stocks of developer ID. This is a very interesting process that we see that it gets crowdsourced, and actually paying people to get those developer ID. And once that developer ID gets revoked, it gets changed instantaneously with a new sample with a new developer ID. So this effect is almost next to none for these attackers. They change it. They have a system. We did a survey of legitimate non-App Store application, and around 50% of them display a dialog installation code. That user used to getting whatever it's doing, and the malware does exactly the same. This fake dialog is allows them to grab the user's password, and afterwards they can use it to whatever they want. In this code snippet, we have basically the code from a malware called Bundle that is actually checking whether or not the user entered the right password. It just runs some bash script, and when they, and of course, if the user entered the wrong password, it will reprompt the user again until he enters the right password. And let's see how it gets used. So in this code snippet, the installer is basically using the password in order to run a bash script. You can see below it pipes the password into a sudo command, and then below we can see how it actually how it looks like in Pokemon. So the password is getting used for all sorts of activity. Among them is consistency. So almost all samples that we see get dynamically download some content from the internet during installation. They're doing it for two main reasons. One is they want to tailor the offers that they give to the user dynamically. So they fingerprint the user, they fingerprint the machine ID, the IP, or whatever they need from to know whatever they need to the user, whatever methods they use, and the result is whether or not to infect the machine, whether or not to give it specific offers and such a thing. And the second reason is to bypass gatekeeper and run unsigned code. So the only thing that you need to do in order to bypass gatekeeper is to remove the Apple quarantine attribute. And once you get code running on the machine, basically there's no reason why you can basically do that whenever you want. It's voluntarily, so browsers, when they download stuff, they will put this flag, but whenever another application like CURL or your own installer can actually, once it downloads, it can remove this flag and just run it without code signing. And we'll see two examples of that. This model is called Share. The main executable of the bundle is just a simple bash script, which all it does is decrypting a file resource folder. This file gets decrypted into another bash script. This has some base64 that gets deobfuscated in memory, which deobfuscates into a third bash script. And this bash script does the actual downloads using CURL. CURL does not, when you download stuff, it doesn't put the attribute quarantine flag on whatever it downloads. And it's using the password. You can see, by the way, you see in the URL that it is sending some metrics to the server. If the server says, okay, I want you to infect this machine, it will download give you the actual installer that gets unzipped using a password and runs. Second example is using the PKG installer, the internal installer in macOS, which allows you to customize it using pre and post install scripts. So these are just bash scripts. So in this example, in a cleaner called Mac Repair, it doesn't have anything in its payload in the PKG. It uses the post install script to basically just download the application from the website and install it into the application folder. Okay, so once you have persistency, it's time to talk about TCC. TCC stands for Transparency, Consent, and Control. This is the Apple's mechanism for getting user consent whenever an application wants to control another application. So it got a lot of improvement in macOS Mojave. So if in the previous High Sierra, it had a few simple dialogues. Now you have for every single part of the OS, like if an application wants to access the camera, want to access the microphone, and there is a long list of other places that the applications want to access, they need to get a dialogue, and the user have to press OK. Another big change in macOS Mojave was the whole handling of Apple events, that allows you to automate one application to automate another application. So in High Sierra, what you have to do in order to automate other applications, you have to get the accessibility approval, and that basically allows you to the application that got it to basically control all applications and whatever they are. In macOS Mojave, you actually have to get consent from the user to each and every application separately. So, as I mentioned before, the modules are getting stored as a funnel. So each dialog that the user gets presented with reduces the amount of installs that they actually get through and succeed to the end. So this poses a little bit of a problem for Mac authors. So sorry, for model authors. So let's see how they bypass this. The main trend that we see is offloading these types of dialogues requests from the main installer to a background thread called a daemon. So instead of asking for this permission during the main installation, it will be prompted afterwards. The advantage is first that the daemon doesn't have to be named exactly like the installer, so the user doesn't necessarily associate it with the program that they installed. It can have a delayed run, like after a reboot, after a period of time, and even on demand from the CNC. And the user actually gets dialogue that appears out of nowhere. He has no context. He has no way of knowing what is this program called Max Security Plus. And all you can do is click OK or don't allow. Most of them just click OK. Daemon gets installed using the launch agent, using the launch CTL command. And you can see in this example that some of the properties that it has, first, it has the keep alive attribute, which means that whenever the daemon gets killed, the OS will respawn it. And of course, it's running as root. And if the dialog is not enough, there is some more interesting ways to make them quick. This example from Banjo, basically the user gets prompted with the dialog that says your computer low in memory. The user really doesn't really know what to do with it. But if you click it, it will be a big mistake because let's see what's behind it. That's actually the consent dialog. So even the user click don't allow, you can see that everything gets resetted and goes back to what it was before. And let's see what actually is happening. This window is transparent. So whenever you click whatever's behind it, the click will go through towards what's downstairs. So you can see that what will actually happen when I click the close button is that the user will actually accept the dialog. I don't know what is the reason that transparent windows even exist, other than this method, but they get being used. And as I mentioned before, what happens if the user doesn't click doesn't allow, don't allow. So usually when you click don't allow, in the settings and in the security and privacy settings, the permission gets written without any V in the checkbox. But what happens? But if the malware actually wants to be persistent, it can use an application that is built into the OS. It's called TCCUT. Its only function is reset, and what it's being used for is to remove these security and privacy settings. So so if in this example I just do TCC reset Apple event, and it will actually remove everything that in Apple event, whether it was approved or not approved. And the funny thing is, you don't have to be root to remove it. So you can just run it from anywhere. Another cool feature, apparently when you run it as daemon, let's start with, when I approve an application, let's say in this example on the left, when I approve for terminal to control Safari, I will see it in the security and privacy settings. But when a daemon asks for permission from a user, you will see the dialog, but you will not see, afterwards, you will not see what happens with your approval in the security and privacy settings. I don't know why it's like that. I guess someone at Apple thought that because users doesn't really know about daemons and they're not supposed to know how to install or uninstall them, they're not supposed to see the settings there. But I can tell you it's intentional because if you look at the TCCDB, which is the SQLite database that all the settings for TCC gets written, you can actually see a field called client type. And when client type equals 0, you will not see these settings in the privacy settings. This is also a cool advantage of running as daemon. By the way, if for some reason a machine that gets infected doesn't have SIP enabled, so this SQLite database is protected by SIP usually, but if it's not, then the malware can just edit it and ignore all this shenanigan at all. Okay, so now we hand it over to Roee to tell us about browser hijacking.
Hello everyone. So first of all, I think I'm a little bit excited. It's my first presentation I ever do. And also not in my primary language, this is a double challenge. Let's go. So we're gonna talk in the few next minutes on browser extensions and how malware actor will infect your browser in creative ways. We'll start from browser extensions. Just of the recent changes made in Mojave, so Safari 12 and on, now blocks legacy extensions of the previous version, which is a .txtz version. Also, Apple started to deprecate its own App Store, meaning you cannot commit a new code to the gallery extension. Now you should commit it into the Mac App Store in a new form, which is an app extension. And in two words, what app extension is an application that bundles inside the extension. You can see a sample of the Safari extension window, which all you have to do is just to select the checkbox over there, and you're enabled by this the Safari extension. Next slide, you're going to see how malware actors got adapted to this, how they achieve this selection in creative ways. So here's an example of install core family. You can see everything here belongs to the OS, except this naughty blue frame, which follows the screen wherever the user dragging it on. This is a more sophisticated example of a malware from a bundle X, from Genius family. What's happening here is that the desktop is duplicated and put into the front in a transparent manner. You see the bar of the installation proceeds, and you see soon a pop-up appears in the top of the Windows with a continue button. The user is very keen to click on this continue button, however the mouse is locked on a certain location on the screen. We'll start playing this. This is the continue button. It's hard to see the mouse here, but this is me switching between the windows. You can see that behind is the extension window and the exact location where the mouse is. So by default human reaction, what happens? You just click on place, and guess what happened? You just select the extension. It's enabled on your system now. This is some of the code perspective. You can see it's quite a new thing in macOS Mojave because the malware actors do not intend to write the code in any way. First of all is the function name, which is right click move to point. It's not obfuscated in any way. And second is the cursor application for seconds. Just forgot to mention that the whole installation process is under a timer. After 30 seconds without anything the user performs, the installation continues without installing the extension. Now we move on to a more sophisticated way to inject your browser is via AppleScript. So you probably all know what it is. In two sentences, a language invented by Apple in order to automate between apps, as Omer has mentioned a while ago. And for sure, you can guess that malware actors also use this stuff in order to inject your browser. So in the following example, you can see the bundle X family. First file is my shop coupon, which is a bash file. You go with script code, which is put on your machine in a match or file format. This matcher is fetching AppleScript from a server. Next, we've seen for a long time this hash is quite the same, but the code it fetches from the server is changing. That's a benefit. This whole AppleScript goes into a Python code which activates the AppleScript. And that's worth mentioning. It's under running as a daemon, means if somehow the process gets killed, it's initiated by the OS. So once we gain the automation, as Omer just mentioned, we have another layer of authorization to inject Safari, which is the need to mark the settings that you see in the menu. The allow JavaScript from Apple events means if you want to send some infection to the browser, you should also authorize this setting. You can see on the black box how malwares do it in a silent manner. So they inject the Com Safari Apple entitlements file in two steps. So first of all, they have to enable the develop menu, which by default is not displayed in Safari. You can see the right, they include develop menu to be int1, to be displayed. And second, they create like some combination of keystrokes You can see under there that they take the allow JavaScript from Apple events, make an equal sign and some combination of keystrokes that the malware performs, and by that reaches the vid over there. So the last step before knocking out your browser is entering. They need to enter the root password, which the installer is getting while before. You can see two frames. The first one is a loop, which right till this prompt is appearing to the user. So it reaches 5 times. It tries to prompt it 5 times. And once it appears, it goes to the next step, the next red frame, which is waiting after seconds. Let's guess some of the system is quite low. Then it keystrokes the root password. You can see the second line, the second frame. And then the browser is already all set. You can send the Apple events with JavaScript inside. So this is the code itself that's being injected to the browser. Basically what it does is performing a bidding over sites. It fetches, you see the bottlenecks, it fetches from server some JavaScript code. It evaluates some elements user is currently viewing on the page source, sends back to the server proceeds processing the request, and returns back to the best fitting URL that the user is currently viewing. So this is actually how the user feels during the injection. So the server, as I said, responds back with the best fitting URL. User entering the browser, types something in the address bar, hits the enter key, and you can see the current page is pushed into the right, and on the left is opening something else, which in our case is installer. That's it. Now back to Omer.
And now something that we discovered just 2 days ago, actually, that we already entered into the presentation. So this actor is actually doing man in the middle. So it's basically doing the installation. It drops a program called the Titanium Web Proxy, which actually is an open source that they use as is. They run it as daemon, and it sets the network proxy settings to localhost at port 8003. And then it installs a root certificate to the kitchen. So basically, it allows them to inspect all web traffic, including decrypting SSL. And what it's doing is, but first of all, it starts to run once in your next reboot, and then it's injecting content into Google. Basically, you can see here that the iframe, this is the Google search that the user has done, and the iframe that gets injected into the search results are pushed down, and what you see here is actually search results from Bing that the attacker is actually monetizing on. So basically, this is a very intrusive way to actually, and they actually view and parse each and every session and every connection that the user is doing and interacting whenever they can. So this concludes our part on browser hijacking. And let's talk about the future for a bit. So one of the main changes in OS Nuavi is app notarization and hardened runtime. So notarization service is, in very short words, it's an automated service that scans software for malicious content. That you submit your ready code to Apple, and they will stamp it with their own certificate, and then the user, instead of getting the usual, are you sure you want to open this, they will get a nicer dialogue that is less scary. And basically, notarization service, Apple says that they are scanning all sorts of the code for all sorts of malware. You have to enable the code signing for all executables. And you have to opt in into hardened runtime, which basically a lot of entitlements that you need to specify for a program, whether or not you want to use code signing for every executable pages, library validation, debugging, and all your resource access. So starting at 10.14.5, which was out I think 3 weeks ago, more or less, Apple has started this process to be mandatory for all new developer licenses. So existing application, not yet, but we see that they start rolling this feature to be mandatory in the near future. And I think because it started to be mandatory for new developer already, we are talking about a few weeks until it's probably going to be mandatory for everyone. And it's going to be interesting to see how it will affect the behavior of malware, because it basically mandate you to submit to Apple each and every sample that you create. And if you're doing a lot of polymorphic samples, like a lot of the actors are doing, and up till now you could have signed your own certificate. Now you have to submit each and every sample to Apple. They might even throttle you. I mean, limit the number of samples you can submit. Each submission they say if everything goes fine, it takes around an hour. So it really limits the amount of polymorphic samples you can do. And it allows Apple to really keep tabs on every sample out there. If you think about it, they can have the hash of every sample that they submit. And if they decide to revoke a certificate, probably they can also blacklist each sample that this certificate has ever signed. So it sounds like a good solution. When they detect something is malicious, they can just revoke it completely. And then again, there's Gatekeeper. As we see before, Gatekeeper is actually all this verification happens in Gatekeeper. And Gatekeeper only runs once in the first run of the application. And as we've seen before, it's not so hard to bypass it. And right now, all the main installers and hardware are basically the bundles, the software that in the notarized application is already just an empty shell of dynamically downloaded content from the web. So basically, there is nothing in the application to notarize because it's very, very simple. There is nothing in there. But until this process is going to be mandatory, there is no way that we can know exactly how it will actually be in effect. And if you have any ideas or guesses of how it's going to happen, I'm very happy to hear everyone's opinion on that. Should be interesting. So to summarize this talk, we saw that using social and a little bit of UI automation can go a long way in actually infecting millions of Mac users. You don't always have to use expensive exploits or other sneaky ways. You can just walk in the main door, and it's usually enough. Mojave's new features, while they're probably very good for users' privacy, didn't have a lot of effect on actual malware number of infections. It did change the behaviors a bit. They have to adapt a little bit, but they did it really, really fast, as we saw in the previous slide. And one thing that I would like to leave you with is this hardware that this cute little pucks, what we are calling potentially unwanted applications that a lot of the security community are really tend to ignore. Well, let's think about what we saw here today. These hardware samples that are infecting millions of Macs out there. They have daemons that are running as root on millions of computers. They can get any command they want from their operators, and basically they are an actual botnet. And the fact that they are only doing it for just browser hijacking right now or Sage takeovers and stuff like that to monetize, doesn't mean that in the future, or if they get pressed enough from law and from other agencies, this stuff can be used to whatever they want. And the only fact that right now they're being used for these purposes, just not break the law. Some of them wouldn't care in the future to break the law, maybe. And this means that millions of computers can just be pawned in just a matter of decision. So they really should be treated as real malware rather than just unwanted applications. And with that, I will finish. Thank you very much. Any questions?
Going back to your 26% estimate of infected Macs in your voice, do you know if that's personal or corporate Macs?
We don't make this distinction. I don't know. Just the total max that we observe out there. So we don't have this distinction.
Okay.
Okay.
Do you know if there's any way to detect those transparent windows when I display like a bit of code you could look for, or?
Probably. I mean, it's APIs of the OS. It's not something. It's an API that you just need settings that you have to do in the GUI settings. I don't know exactly which one. Maybe it's an interesting way to look at it, but it shouldn't be a problem, I think. All right. Thank you very much.
Can I ask a question?
Yeah, sure.
So you mentioned that in Mojave, a lot of the new privacy and security improvements didn't do much to thwart the adware attackers. I mean, these new changes do have impacts on legitimate software, but if they're not really stopping kind of the adware, what would you recommend Apple do, or what are your thoughts on that?
Well, I think that basically, first of all, I think that gatekeepers should be a lot more pervasive in the way they check software, because the main problem here is that all these security checks are being done only once and only when and it's only opt-in. So if it doesn't get, if the system doesn't get scanned all the time and this code signing isn't verified all the time, then basically there is no point in doing it, because there is a wide open door when there is a gate.